Welcome everybody. This is our first session in NEET previous year questions for chapter Magnetism and Matter of class 12th. Before this video, we have made several videos in this series for the previous four chapters of class 12th and for class 11th also. And all of those videos are available on our channel's playlist section. We have also started similar series for JE previous year. So if some of your friends are preparing for JE or if you want some advanced practice, then you can watch those videos also from the playlist. And if you find these videos useful, helpful, then do press the like button, share them, and subscribe to our channel. Also, if you want like to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. With this, let's start today's video. Here is our first question, and as per statement, magnetic potential energy when a magnetic bar of magnetic moment M placed perpendicular to the magnetic field. So here the angle between magnetic moment and the magnetic field is 90 degrees. So it's like that magnetic moment points towards this and magnetic field is pointing in this direction. So we know that potential energy is minus P dot B, where that's actually in the form of electric. In electrostatic, we donate dipole moment by P. Here we will be denoting it by M. So M dot P. And as we have dot product, and it will be MB cos 90 minus MB cos of 90, and cos 90 is 0, so potential energy is 0 here. Now let's move to the next question. So magnetic moment and moment of inertia of needle are shown given. It completes 10 oscillations in 10 seconds, the magnitude of the magnetic field. So we have been given time period of oscillation, we have been given moment of inertia, and we have been given magnetic moment of the dipole, magnetic dipole. We have to find the value of magnetic field. Here we can use the relation of time period of an oscillating magnetic dipole in a magnetic field. It is given by time period is 2 pi under root I divided by mb. So from this, t square is equal to 4 pi square I mb, and from this magnetic field is 4 pi square I divided by m into t square. Now 10 oscillations in 10 seconds means for one oscillation it is taking 1 second, so time period is 1 here. So B will be 4 times pi square. Pi square is almost 10, so we are taking it 10. Moment of inertia is okay, we take it as pi square because here it is mentioned in a pi square. So moment of inertia, first is magnetic moment and second is moment of inertia. Moment of inertia is given in terms of pi square, so it will cancel out. Divided by m, that is 10 raised to power minus 2, and t is 1. So it will be 4 into 10 raised to power minus 4, or 0.4 into 10 raised to power minus 3. So it will be 0.4 millitesla. That is option C for us. Let's move to the next question. The magnetic moment of an iron bar is m. It is bent such a way that it forms an arc section of a circle subtended angle 60 degree at the center. Magnetic moment of this arc is we have to find out. So let's suppose initially we had an iron bar whose magnetic moment was m. So suppose this is our initial iron bar and its length is L, such that this length is L, and its magnetic moment is capital M. And suppose its pole strength is small m, so we can say capital M is equal to small m into L. Now we bend it. So after bending, it will look like something this. Suppose we bend it, and let me make it slightly thicker. Okay, good. So suppose this iron bar we had, we bend it into this shape, and the angle subtending at the center is 60 degree given. So suppose here we have center. So this angle is 60 degree. And if we divide it in the half, why we are dividing it in half? Because we have to find out the length, horizontal, perpendicular length. So this angle, this will be 30 degree. Now let's mark some point O, A, B, and C. Now, as this is iron bar which has a magnetic property, so it is acting as a magnet. And if we bend the magnet, or even if we break the magnet into some pieces, then pole strength does not changes. Here pole strength is m, small m, and it will not change. Here again pole strength will stay m, and here also pole strength will stay as small m. Only the length which of the magnet, the effective length of the magnet has changed. So we have to find the effective length, or we have to find the value of the AC. So as we know that arc AC, this arc AC is equal to L, that is the original length of the magnet, and here theta is equal to 60 degree, or 60 degree is equal to pi by 3 radian. So from this, what we can get? We can get the value of OA or OC, because we know that theta is equal to arc by radius, and from this radius comes out to be arc by theta. Arc is L and theta is pi by 3, so radius comes out to be 3L by pi, or we can say it is equal to AO or OC. Now we have the value of OC, so we can find out the value of OB. OB will be OC cos 30. OC is 3L by pi, and cos 30 is root 3 by 2. So it will be equal to 3 root 3L by 2 pi. And similarly, we can find value of BC. BC will be OC sine 30. So it will be OC is 3L by pi, and sine 30 is half, so 3L by 2 pi. So we have all the lengths. Now this curved magnet can be considered equal to a magnet having length equal to AC with pole strength as it is. So pole strength will stay the same, pole strength will be M, and now AC is equal to twice of BC. AC is equal to twice of BC, and BC is equal to 3L by 2 pi. So it will be AC is 3L by pi. Now we can find the pole strength of this magnet. Pole strength of this magnet will be, suppose that is M dash, so it will be, oh sorry, not pole strength, the dipole moment of this magnet, it will be M dash, and that will be pole strength times the length of the magnet, that is 3L by pi. So it will be 3 ml by pi, and ml is equal to capital M. So M dash will be 3m by pi, and equating it, we get option A as the right answer. Now let's move to the next question. In a uniform field is mentioned, magnetic needle performs 20 complete oscillations in the 5 second. So here we have 20 oscillation in 5 second, or we can say time period will be number of time by number of oscillations. So it will be 1 by 4 second. It is time period. Value of I is mentioned 9.8 into 10 raised to power minus 6. So we have to find the magnitude of the magnetic moment of the needle in this form. So again, time period is given by 2 pi under root I by mb, and we have to find magnetic moment of the needle. So m we have to calculate. So t square is equal to 4 pi square I by mb, and from this m comes out to be 4 pi square I divided by b times t square. So m is equal to 4 into pi square is almost 10. I is 9.8 into 10 raised to power minus 6. Now we have magnetic field, that is 0.049. So we can write it like 4.9 into 10 raised to power minus 2 multiply t square. T is 1 by 4, so its square will be 1 by 16. So this get cancelled on 2, and we have here 8 into 16, and in the options pi square is mentioned, so we keep pi square here as it is, into pi square, and this will be 10 raised to power minus 4. So it is 128 pi square 10 raised to power minus 4, and we have to find in the form of 10 raised to power minus 5, so we can write it 128 pi square into 10 raised to power minus 4. So this will be the answer here. So option C is the right answer. Let's move to the next one. An iron bar of length L has magnetic moment M. It's bent to middle to such that its two arms make angles 60 degree. The magnetic moment of the new magnet is. So we have solved similar type of question, only just the change is here that in the previous one we made it in the form of arc, and now we bend it in the middle and to form a two arms, or with each angle 60 degree, or we can say angle between them is 60 degree. So let me show you how it is. Initially we had a magnet. Initially our magnet was like this, and then we bent it into two like this. Now our magnet is like this. So its length was L and magnetic moment was M. So we can say pole strength was small m. As we bend the magnet, pole strength does not changes. And here this angle This angle is 60 degree and this length is L by 2. So what we can do, let me slide this pole strength in the size. So pole strength M here. Now what we can do, we can find the value of this length. If we can find this length A, B, C. If we can find this length AC, then this whole magnet can be represented by a magnet having length equal to AC, having length equal to AC. So this will be a magnet with length equal to AC. So we have to find the value of AC, and pole strength we know that it is M. So now in this triangle, suppose this point is O. In the triangle OAB, total angle is 60 degree. So this angle will be 30 degree. We know this value, that is L by 2. So AB will be, we can say OA sine of 30. Now OA is L by 2, sine of 30 is half, so it will be L by 4, and AC is twice of AB, so it will be L by 2. So new magnetic moment of the magnet M dash will be M into AC. AC is L by 2, so ML by 2. And we know from the original magnet that capital M is M into L, so it is capital M by 2. So option A will be the right answer here. Now let's move to the next question. A bar magnet is hung by a thin cotton thread in uniform horizontal magnetic field and is in equilibrium state. The energy required to rotate it by 60 degree is W. Now torque required to keep the magnet in the new position. So again, I think we have solved this type of question. So let's do it again. So initially magnet is in equilibrium state. So if it is in equilibrium state, it does mean that torque acting on the magnet is zero, and we know that torque is M cross B or MB sine theta. And if this value is zero, means theta is zero. So M and B are initially aligned. So we can say initial potential energy, that will be minus MB cos of initial angle, that is 0. So initial potential energy is minus MB. Now we have to rotate it by 60 degree. So our final angle will be 60 degree. So potential energy final will be minus MB cos 60, and cos 60 is half. So it will be minus MB by half. So work done, that is change in potential energy, final potential minus initial potential energy, so minus MB by 2, negative negative of MB, so it will be MB by 2, or we can say W is MB by 2. And now we need to find the amount of torque required to hold the magnet in the new position. So for that we can find the amount of torque acting on it due to the magnetic field, and if we apply same amount of torque in the opposite direction, then it will be kept in that position. So torque acting due to magnetic field will be M cross B, and as angle is 60 degree now, so torque will be MB sine of 60. So torque is MB root 3 by 2, and we know that MB by 2 is equal to W. So torque is equal to root 3 times W. That is option B for us. Now let's move to next question. Following figure shows arrangement of bar magnets in different configuration. Each magnet has a magnetic dipole moment M. Which configuration has the highest net magnetic moment? So each has a magnetic dipole moment M, and we know that it is a vector quantity. So if it is a vector quantity, means we can arrange it in the according to the vector. So inside a magnet, P will direction of P is S to N. So for this we have like this, and for this magnet we have like this. For here we will have for first magnet and for the second magnet. For first magnet it will be something like this, and for the second magnet it is something like this. Again here we have something like this and this. So effectively what we have in the first case, we have two vectors each of magnitude m at 90 degree. So in option A we have m and m, and their resultant will be given by m square plus m square plus 2mm cos of 90. Cos 90 is 1, so it will be root 2 times m. For option B, both vectors are in opposite direction, equal in magnitude, so their resultant will be 0. In option C, both vectors are at 30 degree angle, so their resultant will be m square plus m square plus 2m square. Cos of 30 is, that is root 3 by 2. So it will be 2m square plus root 3m square. So that will be m outside with 2 plus root 3. And coming to option D, it will be, they have angle 60 degree with, between them. So it will be m square plus m square plus 2m square, and cos 60, that is half. So it will be m square plus m square. Okay, we made a mistake here, I think. So that was 2m square plus 2m square, 4m square. So it is 2m, not root 2m. So it will be root 3m. That will be root 2m because we have a cos 90 here. So cos 90 is 0. I got confused. So it is root 2m. So, and we have to find the highest, that which of these is highest. So if we compare A and D, we know that root 3 is greater than root 2. So A is cancelled out, B is 0. So now we have to compare between C and D. So if we compare, this is under root of 2 plus root 3. 2 plus root 3 is, root 3 is 1.73. So it will be 3.73. So in under root it is 3.73, and if we compare that, we have here 3 in under root and here we have 3.73 in the under root. So option C will give the highest magnitude. So C will be the right answer here. Now let's move to the next one. Bar magnet of magnetic moment M placed at right angle to magnetic induction P. If the force F is experienced by each of the magnet, the length of the magnet will be. And we have to find out length of the magnet. Now it is mentioned that magnetic moment is right angle with the magnetic induction. So we can say M is perpendicular to B. And it is not mentioned that whether this magnetic field is uniform or not uniform. And in this type of question, we considered it by default that it is a uniform field. So in case of uniform field, the normal force, the translational force or 1D force, that is given by magnetic moment into a rate of change of magnetic field, it comes out to be 0. Why? Because if magnetic field is uniform, then this factor is this derivative reduces to 0, so force comes out to be 0. So it means the force here, the mentioned force in the question is about torque, and we know that torque is equal to m cross p for a uh, for a magnetic dipole, and here angle between m and b is 90, so torque will be m into b. Now it is mentioned that if a force F is experienced by the each pole of the magnet, the length of the magnet will. So let's now come to a magnet. Suppose this is our magnet. These are its two poles, and each of the pole experience a force F. And these force will be in the opposite direction, only then we will get a torque. And if L is the length of the magnet, then each force will be acting at a length L by 2. So total torque by this force will be Fl by 2 plus Fl by 2, that will be Fl, and this torque should be equal to the torque of the magnetic field because this force is acting due to the magnetic field. So we can say Fl is equal to mb, or L is equal to mb by F. So option A will be the right answer here. Let's move to the next question. So bar magnet length L, dipole moment m, bend in the form of arc as shown in the figure, and the new magnetic dipole moment. So option B is the right answer here, and we already solved this question. Let me show you where it was. I think, yes, this was the question. This was the question which we already solved. You can go in the previous timestamp of our video, and you can find the solution. Now let's move to the next one. So here we have short bar magnet with magnetic moment is mentioned, placed in uniform field. Magnet is in stable equilibrium when potential energy is. So when magnet is in stable equilibrium means angle theta between M and B is 0 degree. So potential energy in this configuration will be minus MB cos of 0. So it will be minus MB. And minus of m is 16 into 10 raised to power minus 2, and b, sorry, value of b is 16 into minus 2, and m is 4 into 10 raised to power minus 1. So it will be negative 64 into 10 raised to power minus 3, and it will be 0.064 joule potential energy. So option D will be the right answer here. So with this, we end this video here. Hopefully what we have covered till now is helpful to you. Again, if you find this videos helpful anyhow, then do press the like button and share it and subscribe to our channel. Also, if you have any doubts or suggestion, you can put them in comment section. I will try to resolve them or implement them. And if you want to support us financially, then you can scan any of these QR code in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, again, thanks for watching, and we will meet in next video.